Okay, so good day again, everybody. Today we're going to be looking at circle theorems, right? More or less the geometry of a circle. So in the class when we did measurements, we looked at the parts of a circle that include radius, diameter, chords, segments, sectors, etc. All of those will be the prerequisite knowledge for today's class. So if you all did not know, or you did not recap or revise the measurements handout, which we did a couple of weeks ago, then certain things in today's class you all will not be able to follow, right? And that would have been your fault, of course. So I'll just quickly do a recap, okay? So here we have the diameter, a diagram showing the diameter and the chord. So as we can see, the diameter, it runs from it touches 2 points on the circumference. The circumference is right around the perimeter, basically. And as we can see, the diameter, it touches the circumference at 2 points. However, the diameter, it passes through the center of the circle. That is the point O here, right? The chord also touches the diameter at 2 points, as you can see here with P and Q, right? Just note that it's supposed to be P and Q, not A and B here. So it's supposed to be chord PQ. So that being said, it makes the diameter a chord because a chord touches the circle at 2 points. As you all can see here, the straight line joining any 2 points on the circle is called a chord. So the diameter is a chord. However, the diameter is the largest chord of a circle. Now, PQ is not a diameter, right? Because for it to be a diameter, it must pass through the center of a circle. And I would have covered that when we did circles and measurements. Right, so let us look at arcs now. So here we have a circle. And as you all can see, the red part here, PQ, this is the smaller part of the circle here. So an arc is part of the circumference. We did arcs already when we did measurements as well. So this PQ here is called the minor arc. And this black part here is called the major arc. So this is the minor arc and this is the major arc. Any questions so far? Yes, Galaxy? Your hand raised?
No, sir, that was a mistake, sir.
Philip, you have to sign in with the correct name, right?
Yeah, that's what I know do.
Oh, okay, all right. So segments.
Yes, sir, that was a mistake.
No problem. So here we have a chord, right? And it touches the circumference at 2 points, so it's called a chord. And the distance between the chord and the circumference is called a segment. So here we have, this part here, we have a minor segment, right? And on the top part, we have a major segment. So here we have minor segment, major segment. You all following? Please stop me if you have any questions, right? Right, so now we are going to be looking at a sector. So here is I remember I told you a sector is more or less like a pizza slice, right? So here is the center of the circle, which is O, and we have two radii. OA is a radii and OB is another radii. Sorry, we have two radii. OA is a radius and OB is a radius. Of course, radius is the singular and radii is the plural. Okay, so we have two radii. And between these two radii, we have two sectors. So here is the minor sector, and here we have the major sector. Any questions so far? No?
No, sir.
Okay. The tangent of a circle now. Now, any straight line that just basically touches the circumference of the circle at any point in the circle or the circumference, it is called a tangent. So here we can see we have three tangents. We have the tangent to the circle at B, we have the tangent to the circle at C, and we have a tangent to the circle at E. So we have three tangents in this diagram here. So far we've looked at arcs, we've looked at sectors, we've looked at tangents, we've looked at chords, diameters, etc. So now we're actually going to get into the theorems. Okay? There are 9 theorems that you will need to learn and need to understand. Every theorem that I do, I'm going to give you all a minute to screenshot it or to take a picture if you're using a laptop. Take your phone and use it and take a picture, or if you have a laptop, use your snipping tool and snip it, right? And put it in a Microsoft document because you're going to need all the theorems when we start to answer questions just now, right? So theorem 1. This theorem says that the straight line drawn from the center of a circle and perpendicular to a chord must bisect the chord. So here we have a chord AB, and we have the center of the circle here. If we were to draw a straight line coming down from the center to touch the chord, what we get here is a 90-degree angle, right? And this here is what I'm talking about when I say perpendicular to a chord. This is what perpendicular means. Perpendicular means the lines meet at the right angles, right? So in other words, this line we draw here, it will bisect the chord and cut it exactly into half. So here we will have AMB, and AM will be equal to BM. So in other words, if this distance here was 3, then this distance here was also 3. Any questions so far? Okay, taking your silence as a no. Okay, theorem 2. Remember, I'm giving you a little time to screenshot and take it, all right? Don't write it down, don't try to write it down because you ain't gonna finish today. So theorem 2, the straight line is drawn from the center of a circle to the midpoint of a chord is perpendicular to the chord. So if we have a chord AB, as you all can see here, and we have the center of the circle O, we can say that OM bisect the chord, and therefore M is the midpoint of the chord AB. In other words, it's the center, basically, right? So we can say that OM is perpendicular to AB. It's very similar to the first rule, right? And here we can see that OMB is 90 degrees, and OMA is 90 degrees as well. So we can say that OMA and OMB is 90 degrees. Of course, I want you to notice that the angle that we're talking about is in the middle, right? Which is M. It always goes in the middle. Right. Theorem 3. A diameter subtends a right angle at the circumference of a circle. Subtends just means basically to form, right? It means when two straight lines meet up, they form something. So a diameter forms a right angle at the circumference of a circle. So we have a diameter here. Remember, the diameter passes through the center of the circle. So AB passes through the center of the circle, right? And if we were to draw a line from here and here, it will meet at point C, right? So the rule is telling us here that once we have two lines that connects to the diameter here, the angle that is formed over here by the circumference is a 90-degree angle. Okay? Any questions so far? No? All right. Theorem 4. The theorem is basically the part in green there, right? Theorem 4. The angle subtended by a chord at the circumference of a circle and standing on the same arc are equal. So here we have a chord, right? And this whole thing here, this whole thing on the top here is the arc. So they're standing on the same arc, right? So angles subtended by a chord, which is AB, at the circumference, they are subtended to the circumference here, right? 2 points on the circumference, A and B. And standing on the same arc, so they are on the same arc, they are equal, right? So this angle is equal to this angle. However, if we have it in the bottom here as well, as is the case over here in this circle to the bottom here, the angles here are also equal. So this x and x is the same thing as what we have on the top here, right? So x and x will be equal to each other, and then y and y will be equal to each other. I want you all to also note that x and y will not be the same. Only x and x will be the same, and y will be the same as is the case here. So again, this rule says that angles subtended by a chord at the circumference of a circle and standing on the same arc are equal. So these angles are subtended by a chord and to the circumference, and therefore they are equal, both on the top and on the bottom, right? This angle is equal to this angle is equal to this angle. However, x is not equal to y. Just note that, okay? Let's look at theorem 5. I'm going to give you a little minute to more or less take it down. You are finished? Okay, so let's read the theorem. The angle subtended by a chord at the center of a circle is twice the angle at the chord, that the chord subtends at the circumference standing on the same arc. So you have A here and you have B here. This is the chord, right? If we have this angle going up here to form C, and we have another, if we draw another angle that forms from A to O and then O to B, we can see here that if this is, let's just say this angle here at C is 60 degrees, then the angle here is twice that, so it's 120 degrees. That's basically what this rule is telling us, right? Now this rule is frequently tested in CXC, so make sure you remember this theorem, right? It's not the only one that's tested, but I've seen it come a lot. So we can also see here that this theorem is also applicable to reflex angles A, O, B. But in this case, it will be twice the angle subtended by A, B. So by A being the alternate segment. So this is the alternate segment here, right? Now you have to remember this theorem as well, right? Because this is the next piece of the theorem that's very important. I'll repeat it again. This theorem is also applicable to the reflex angle AOB. This is a reflex angle here, right? AOB, and it will be twice the angle subtended by AB in the alternate segment. So this is the angle subtended by AB in the alternate segment. Alternate just means in the more or less the kind of like opposite segment. So this is what I'm talking about here. So if this is Y, then the reflex angle here will be 2 times the value of Y. So if Y here is let's just say 120, then over here will be 240. Anybody have any questions so far? Anybody?
No, sir.
Right. Okay. So theorem 6 now. the opposite angles of a cyclic quadrilateral are supplementary. In other words, they are telling us if you add any two of these angles, so let's say you add A and you add C, you'll get 180 degrees. Let's say you add B and you add D, you'll get 180 degrees, right? So that one was very easy. Theorem 7 now. The angle formed by the tangent to a circle and the radius at the point of contact is a right angle. So we have a tangent here. SAT is the tangent here. Right? Remember, a tangent is just a line that touches the circumference of a circle. And if we were to draw a radius from the center to the circumference, it's telling us that it would touch the tangent at a 90-degree angle. That's basically what it's telling us here. That's all. Right? So OAT is 90 degrees and OAS is also 90 degrees. So OAS and OAT are therefore equal to 90 degrees and they are also equal to each other. Any questions so far? I hope you are taking taking pictures of the theorems because you all need them just now, okay? Theorem 8. The two tangents that can be drawn to a circle from a point outside of the circle are equal in length. So we have a point O here, and we have 2 points on the circumference here, A and B. If we were to draw two straight lines from O to A and O to B, then the 2 points OA and OB will be equal to each other. That one was pretty straightforward and easy. The last theorem, the angle formed by the tangent to a circle and a chord at the point of contact is equal to the angle in the alternate segment. I'll repeat it one more time. The angle formed by the tangent, you're seeing this tangent here, right? To a circle and the chord is AB. And as you all can see, you have an angle forming right here, right? So this is the chord AB, and this is the angle here, is equal to the angle in the alternate segment. So the alternate segment is this next angle here. So here it's telling us that A is equal to A, more or less. Yes, this is the alpha symbol, but I'm saying A because that's what you all remember it as, right? If I say alpha, I might confuse some people. So here we can see that SAT is the chord, and AB is the, SAT is the segment, the tangent, and AB is the chord, right? And angle ACB is the alternate angle, and we can see here that angle BAT is equal to angle ACB. And that was the last theorem. Now, let me just tell you all one thing though. When you are learning the theorems, do not learn it as theorem 1, theorem 2, theorem 3. What is important is the part in green, not which number the theorem is. Because I've seen in when I give past paper questions to my students, I ask them to solve a circle theorem question, and when they have to justify their answer, they will put using theorem 5. What is theorem 5? Because I was telling the class on Wednesday that different textbooks have different numbers of theorems. This handout here has 9 theorems. Sometimes the theorems are more, sometimes they are less, depending on the textbook, right? It's not fixed. But here it's broken up into 9 different theorems. Sometimes they combine the theorems because of similarity, etc. I've seen it in some textbooks, right? And of course, what I do in theorem 9 might be theorem 5 in the next textbook. The order in which theorems are written is not important. So please, when you're writing your questions and they ask you to justify your answer, do not go and write theorem 5 or theorem 6. Please put in brackets what the theorem actually is. Okay? Everybody okay?
Yes, sir.
All right, Kaliam, I think we've seen your joggers. All right. I think you hear me. So I'm going to give you all this example here to do for me. I want you all to try it. And of course, give a reason for your answer. I'll be back in 1 minute. Okay, anybody finished? I want to share this answer.
Yeah. Yeah, I finished.
All right. You want to share your answer, Sandra, and tell us what you get and how you get it?
I got R is equals to 5 using Pythagoras theorem.
Correct. So here we are seeing we have to find R squared, right? So let me just do it on Microsoft Paint. I don't have the whiteboard to use anymore. Okay. So as you all could see here, right, we are given a circle and we have to find R. Now R is basically the hypotenuse of the circle. And we know the square of the hypotenuse is equal to the sum of the square of the other two sides. So let's find the other two sides. This is capital B here. So this side will be small b. So it's b squared. This is m here. Wait, sorry. This is O here. So here will be O as well, small o. So R squared is equal to whatever it is, which is in this case 3 centimeters squared plus 4 centimeters squared. So R squared is 9 centimeters squared plus 4 centimeters squared. R squared is therefore 25 centimeters squared. But remember, we don't want R squared. We want R. So to get rid of a square, we have to find square root. This cancels with this. And of course, the square root of that will give us 5 centimeters. Okay? or you can have simply used theorem 2, right? And it says here that the radius of a circle is, a straight line drawn from the center of a circle to the midpoint of the chord is perpendicular to the chord, and it forms a 90-degree angle here, right? And because it forms a 90-degree angle here, we would have known that it's a right angle, and of course we use Pythagoras' theorem. Okay? So on to our next question. This question here. Try it. Anybody figure it out?
Yes, I figured it out.
All right, let's hear what you get.
For X, I got 90.
Okay. And which theorem did you use?
Theorem 3.
Yes. So let's see. Theorem 3, which states that the angle in a
It's like triangle.
yeah, and clearly we can see in this circle here we have a semicircle, because this line here cuts the circle directly in half, so we have a semicircle, right? So the angle in a semicircle is equal to 90 degrees if it touches the circumference here, right? That being said, we know that angle ACB is equal to 90 degrees. Okay? So that means that, and remember, all the angles in a triangle add up to 180 degrees. So that means that X plus 2x plus 90 is equal to 180 degrees. So 3x plus 90 is equal to 180 degrees. Of course, all of these are degrees, right? So we want to get rid of the 90. So positive 90 goes across. 3x is equal to 180. Take away 90. 3x is 90 degrees. So we want to find out what is x. So the next thing we do is take across the 3. So x is 90 divided by 3, which is equal to 30 degrees. Everybody okay?
Yeah.
Yes, sir.
All right. How are you? Are you guys following?
Yes, sir.
Huda. Huda. Tom. Tom Ende.
Come, yes, sir.
Newton, you following as well?
Yes, sir.
All right.
So you call me, sir?
No, Miguel, but you're following?
Yeah.
All right. Sorrenta, are you getting through? Sorrenta, you there? Sorrenta, no, you're there, no?
Yeah, sir.
All right, great. Okay, so on to our next question, and I will call on somebody to answer these questions now. Okay. Look at this question here. Example 3. Try that question for me. Can we correct now? I'm going to call on somebody to tell me what they got. So tell me, please, Dion? Dion, what did you get? Dion, you there?
Yes, we are here. Yeah.
All right, tell me what you get.
I got 110. 110 degrees.
No problem. And how you, yes, that's correct. And how you get that?
Well, minus the 360 degrees from 140 degrees to get 220. Multiplied by half, 100, 110.
Okay, and which theorem you use? Dion, which theorem you use? So yeah, he is correct. So we would have used theorem 5, right? Which states that the angle subtended by a chord at the center of a circle
Sorry, it's back.
twice. How lucky are we to have you in our class?
Okay, the sarcasm.
No, that's not sarcasm. That's genuine love. The circumference. So that's the theorem that we use there, right? So that being said, now that we know that, we know here that this is 140, right? So angle AOP is a reflex angle. And we know since it's a circle, everything adds up to 360 degrees. So 360 degrees, take away 140 degrees is equal to 220 degrees. Okay? So what does that tell us? That's telling us that to find angle C, right? Remember, this thing here, the angle, which is 140, is twice, as you can see in the theorem, it's twice the amount. So if we want to find out angle C, we have to find out what is half of that. So 220 divided by 2 will give us 110 degrees. So this here is 110 degrees, and this here is twice the value of that, which is 220 degrees. Any questions?
No, sir.
All right. I hope the people who are staying quiet have no questions, because just now we're going to do past papers. Okay, Dion, thanks, and I'll get a message there. Next example, do this one for me. Oh, let me take a rule while you all do this.
Yes, sir. So I'm in
Anybody leave after the rule is called before the time is over? I'm putting you all absent, right?
So I wasn't here for majority of the stuff, so I don't know what you're doing for this, to be honest.
Okay, but you're gonna have to look at the video when it goes up on YouTube, right?
All right.
But still try to follow.
Doc, who audio is that, babe?
Oh, how about just ignore that?
Okay, sir.
Sanjay, I'm gonna try something, right? See what control you will have over the screen. What can you do with Sanjay? Okay, I see what you can do. Okay, Sanjay, thank you. I need to get back the screen now, Sanjay. Did you stop?
Wait, now, so you can't get back to the screen?
Sanjay, you need to stop, right?
I didn't do nothing.
Oh,
How do I give you it back?
Yo, take a follow audio now.
Master the intro?
Yeah, the remote control is like really hard to use because it has a delay.
Yeah, but I just wanted to see what it was about. Can we correct now?
So I get 117.
117. That's incorrect. Just kidding.
Knew it.
Okay, so can you all tell me which theorem we're going to use here?
Theorem 4.
Yes. Which says that angles subtended by same chord, the same segment are equal. Okay? So if that is the case, then if this is 63 here, just now, if this is 63 here, that means that over here is also 63. Okay? So angle ADB is 63 degrees. Let's look at the next part of the question now, part 2. This would have utilized theorem 6, which says that opposite angles of a cyclic quadrilateral are okay. And how do we go about doing this? Since we know that they are since we know it's a cyclic quadrilateral, and we're looking at AEB, right? It's cyclic because, as we can see here, just now, forms a thing, right? A quadrilateral. So to find angle AEB, it will be 180 degrees. Take away 63 degrees, right? And this will give us 117 degrees. But this degrees, is it degrees Celsius or degrees Fahrenheit? I'm going to ask somebody here. Tell me, please, Angelica.
Excuse sir, I tried to do it, but I did it different. I still get the same answer.
Okay.
I add 63 by 63, and I get the answer, and then I take it away by 360, and then the answer I divided by 2, and I still get 117.
Nah. That's wrong. Angelica?
I confused now.
But the degrees that we are using, is it degrees Celsius or degrees Fahrenheit?
Celsius.
Okay. Bala, what do you think?
I think it's Celsius.
Oh my God, all crazy, you know, it's just degrees Celsius and degrees Fahrenheit is for temperature. This is not temperature.
Tons.
Oh. Wow. I was staying quiet just to hear them answer.
Okay.
Wait, man, I'm Celsius there.
Yeah.
And I was seeing what the student doing chemistry.
School really needs to open back up for all of you.
Okay, Marcel, I know seeing your message here. Don't worry, in practice you'll get perfect. Angelica, what seems to be the issue with you? What is giving you trouble?
So I just take a while to understand math, so.
Okay, no problem. But you see with this, all you have to do is go through the handout. I'll send it to you as soon as I'm finished, right? There are 1, 2, 3, 4 more questions I want to give you from the handout, and then I'll send it for you all, okay? But the problem with the key to passing this is memorizing the theorems and using the theorem. So when it comes to passive and you actually see how it's applied, well, it will confuse you a little more, but it's actually very simple to use. And the good thing about it, in the multiple choice, they're not going to bring anything too difficult for you all, but you still have to memorize the theorems. Yes, Cheyenne?
You could just explain about the second part.
Sure, no problem. Well, you can see the orange part here, the yellow part here. It's a cyclic quadrilateral here, right? So that's why I know we are using the cyclic quadrilateral part because it involves piece of the quadrilateral, right? So the theorem says that the angles in a cyclic quadrilateral are 180. So we know it's 180. So I just say 180. All of this will add up to 180, right? So 180 take away 63 and I got 117.
Okay.
Yeah. So let's continue then. I'm just giving you a little confidence booster. If you all think these questions are difficult, you ain't see nothing yet. We're not see them past papers. Oh God.
So how does a confidence booster, sir?
That there claim was sarcasm.
Okay.
Yeah.
Cool.
I'm good at English and I know what is sarcasm, you know.
But so you tell me you feel English.
Shut up.
But tell us that, Khalil.
I probably said I was never good at English, but I could speak better than elderly, so whatever.
Cap, big cap.
I could speak two languages. I could speak proper English and I could speak broken English.
Just speak.
Cool.
I swear, if Miss Rama hear me talk sometimes, she might faint, you know. Oh, my English is horrible.
No wonder you had fail, sir.
I did not feel it. I just not so good at it. And I can't spell.
You got you.
No, I got to.
Cap.
Yeah. But I can't spell to save my life.
So spell trigonometry, sir.
I can spell that obviously.
Yeah, because he's a
I
math
remember-
teacher. You always teaching
I
that.
remember when I was writing CXC and I tried to use the word important and I put EMPORTANT.
Nah, so I'll go on there later.
I don't want to be the one to talk since I just said it was Celsius. That's just really bad, so.
Was that Bala?
I don't want to be the one to talk since I just said Celsius, but that's really bad.
Yeah, but of course.
Okay, ice cream cone.
Spasms.
CELCIUS.
Correct.
Yes, I can spell now, but back when I was a student, I was horrible at spelling, but I'm still not perfect, but I'm getting there.
Cool.
I speak 4 languages.
But you spell Celsius.
That's great.
Spoken English, Chinese, and gibberish.
That's very good. My English is very good. Sometimes when I speak, I try to sound very photosynthesis, you know?
Try to sound like a plant.
Yeah, very good. Very photosynthesis.
Sanjay, you just don't know
Just
the
shut
big
his
words,
eye,
right?
go
We
down.
hate because you don't know the big words.
So, what were you trying to say?
Right.
When I
So
speak properly,
sophisticated.
when I speak properly, I sound very chlorinated and very photosynthesis.
Yeah, I said.
So stop talking, sis. Just stop talking.
Yes, yeah, for real.
Stop talking.
Nah.
Yeah, just give up.
Okay, shut up and do the question. How are you? Anybody figure it out?
So we're doing the 2 questions, right?
What's that?
We're doing the 2 or 1?
Which 2? What do you mean 2?
The
Give us this question some other day. The same question.
Yeah, that was the Wednesday class.
So the answer is 720.
720. Okay, so you're dealing with a circle, right? Where the largest angle that you could possibly get is 360 degrees, and you get 720. That's excellent. You can be called you could make a theory. You're a new theorist, a mathematical theorist.
Thank you.
You're most welcome.
Yeah. I could put you out of business.
720. Where is it? You could put me out of business?
Yeah.
Not in your wildest dream.
Okay, cool.
Okay, let's take it real low, right? And it's like almost 11:30 already.
It's 10:15.
It says
I know,
10,
right?
16, sir.
10:15.
Well, I was trying to.
So you slightly play maths too.
Me, I can't do math in my life, boy. I got a 5 in maths.
No wonder why.
Yeah, but the better the higher the grade, like if it's 5, 6, 7, the better the mark, you know? Like
Yeah.
so like a 7 is always higher than 5, right? And mathematically speaking, 7 is greater than 1. So if you get a 7 in maths, that's actually real good.
I so serious. I'm going to tell my mother that, you know.
Hey, oh God.
You know, you're this too.
So you sound like my cousin, like if you're talking about something in bio or chem or something, he'll try to make up all kind of madness and sound stupid. So.
Excuse you, am I sound stupid?
Yes. No offense, but yes, she.
I never stay sounding stupid, so I say my cousin.
But Colleen, you tell me I sound stupid? Hold
I
on,
never say that. It's
let me just
it's
go and edit
Miguel who
the
say
SBA
it.
mark. Let me just go and edit the SBA mark. Give me 1 second.
Edit it. It's already up by CX, you know,
Yeah,
kind
I
of
was
stuff.
just about to say that.
Go ahead and do what you want to do.
I'm gonna kick you out of the class. Every class I come in, I'm gonna kick you out. Say, well,
Nah, 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 nah.
Pass your SBA exam. Okay, let's continue. All right. So we can see here that it's an isosceles triangle, right? And obviously we know that base angles are equal to each other. So if this is 2x, that means that here is also 2x. Okay? Yeah? So angle ODA is equal to 2x. Next, we are required to find angle DBT. And DBT is how much? That's this angle here. DBT is also 2x because there's a theorem there that we use. It says that the angle formed by the tangent, and this is a tangent here, right? The angle formed by the tangent to a circle and the chord at the point of contact is equal to the angle in the alternate segment. And this here is the angle in the alternate segment, 2x, right? Because of that, we know that that 2x has to be equal to the angle by the tangent here, which is the 2x. Any questions there?
Oh, sir.
I'll just put theorem 9 here, right? You all could know what theorem 9 is. THEOREM 9. Okay, and from here we can see that OA is equal to OC. All right, let me just show you all that here. OA is equal to OC. Right, so we can write that. OA is equal to OC. And since we know that, we can safely conclude that angle ACO is equal ACO, yeah, is equal to X. Because again, this is a isosceles triangle, and base angles are equal. So if this one here is X, this means that this part here is also X. Yes, people? Hello?
Yes, sir.
All right. So next we are required to find angle COB. Angle COB is what?
Cup.
Really? Thanks for the help. You're so bright. What is the answer, anybody? And tell me why.
I don't think nobody really knows.
What kind of triangle is cobweb? What cup?
It is a 90-degree angle triangle.
No.
Yeah, isosceles. It is
Okay,
a
which theorem are we going to use? Which theorem are we using?
Theorem
isosceles
5.
from 4.
J.
We are using theorem 5, which says that the
Say
angle,
that.
right? Well, yeah, that's what I didn't say wrong. The angle at the center of a circle, which is angle COB, is twice that at the circumference standing at angle CAB. That's this here. So if this is x, and if it's twice the amount, it's twice the times x, so it's 2x. It's twice the size of x, so it's 2x. Yes, people? Again, the theorems are important and you need to know it, right? This is one of the challenging topics in maths. But it's also very easy to understand. It's challenging if you don't know the theorems, but when you get to know the theorems, it's very easy to follow through. And the questions tend to be, they look difficult and they look very confusing, but they're actually not, okay? So let's continue. Another question. Try example 6 here.
So with the picture going.
Yeah, just now, triangle something.
So my answer is 22, so I get 22.
How you get which theorem I use?
A multiple. I don't know. I just do work and I just get 22.
No, Kaleem, you can't just guess and do
No, I didn't guess. I actually use my calculator and stuff, but I don't know if my answer correct.
Yeah. Tell me reasoning. How you get 22?
Calculations.
Let me guess. You take away 180 from, sorry, 136 from 180 and you get 44 and you divide 44 by 2 and you get 22.
Yeah. No, no, and I divide it. And I divide it. No, I divide it and then I divide it by 2 and that's my answer.
Nah.
So the work it wrong by my answer, correct?
Go and beat in some cold water.
Wait, but my answer correct, sir? That's all I want to know.
Partially. It was partially correct.
Well, so if I do it like that and I get it correct, you know, I did off for 6, you know, so.
Okay, all right. Do it now.
Okay,
see if you get it correct. Yeah.
Yes.
So give me my 5 one time.
If what?
You know, 5 one time. Yeah, 5 is higher than 1, as they say, so.
Of course.
Right, and 2.
And for those of you who did not submit an SB and you're going to write the maths exam, because I've seen some people who didn't, well, not here right now, but those people who did not submit an SB and it is be in the classes sometimes, when they write the exam, they will get a U, right? that U stands for university. So they will automatically go from Form 5 to university. So that's, you know, that's great.
Are you so? What do you really
Are
mean?
you
What does it
little?
mean?
Wait, but people really didn't submit their SBA. Some people didn't do that.
Yep.
For
A
real,
couple
though,
of people
like,
will.
that's
I know.
crazy.
What? Tell him we're not calling any names.
Okay.
So it really have a U?
Yeah. University way.
What?
Ungraded.
No,
It
but like,
really means
seriously.
ungraded.
Ungraded.
Oh,
And as long as you don't submit a SBA or a paper 3, you get ungraded. Or if you didn't do any one of the papers, let's say you do the multiple choice, you do the SBA, and you didn't do paper 2, if it was under normal exam situations, you would get ungraded.
okay.
Yeah.
Ah.
And
So
of
my
course, this is
answer
just a
correct,
disclaimer.
so-
This is just a disclaimer. Only grade 1, 2, and 3 are accepted in CXC, right? Not the stupidness I was saying before with 5 and 6 and 7. That was just jokes for those of you.
So I aiming for 5, sir.
Yeah, man. All right, let's hit your 1 cloud.
But you the one who say a 5 is a pass.
And I
7
just
is a...
say I was being sarcastic.
And I being sarcastic too, so.
Hey. Very good. You're very good in English class then. That's good.
Slight.
All right, I'll distract him, man. So let's see now.
Oh, yeah?
Yes, you.
But you the one who bring up the convo.
Okay, shut up.
Who start the convo,
So
actually?
A, E, D. We want to find angle E, which is here. And of course, we can see it's along a straight line. And we know a straight line is how much degrees?
180, sir.
Correct. So 180 degrees. Take away 136 will give us 44 degrees.
Right.
So here is 44.
Oh, well, I ain't right there. Bye, man. Answer correctly.
Wait, oh gosh, I done the wrong thing. Sorry.
You wicked, eh?
That's correct, sir.
That's the next one. Sorry, yes, that is correct. I was just checking to make sure you're all paying attention, right? So very good, Sanjay. So
I was paying attention too.
A, E, D, that's here,
I really knew I'm later.
is equal to 90 degrees. And the reason for that is because of which theorem?
Theorem 4.
No.
5.
Theorem 6.
6.
One would be that.
Opposite angles. Sorry, the angles in a semi circle is equal to 90 degrees Celsius or Fahrenheit, Bala.
It doesn't matter, so because it's just
Nice,
degrees.
degrees.
Very
I'm
good,
paying
Bala.
attention.
Very good. You are paying attention. Correct.
I hate you for that question before, right?
No problem. It's a love. It's a love.
So stop picking up my talk, please.
Oh, sorry. I didn't realize you went on your get copyright and patented.
Yeah.
CDA. Right? Anybody can tell me what CDA stands for? Not Sada wrote here, Sanjay.
So, controllers for direct exponent.
No, Shagarama's Development Authority.
You serious?
Yeah, I'll never went Shagarama's and see CDA writing all over.
No, in class.
So let's say we have to find angle CDA, right? So we want to find angle D. It's 136 take away 180. Sorry, 180 take away 136. Right? So that's how I got the 44 there. You all remember that? Okay. And then the third part, we have to find angle A, B, C. So how do we find angle A, B, C? That's this angle here. we know that the angles of a cyclic quadrilateral are equal to 90 degrees, right? So that's theorem 6. So it's just basically 180 degrees, take away 44 degrees, which will give us 136 degrees. Okay? Let me just put the angle, the theorem that I use here. This is theorem 6, which says that opposite angles in a cyclic quadrilateral are supplementary or 90 degrees, right? Equal to 90 degrees. Any questions so far? You see, it's not difficult there. No questions? All right. Question 7 now. One moment.
So your mic's on it, like a pot bubbling.
A pot bubbling.
But I still shine a while. It's one of
Is it still sound like a pot bubbling?
No.
Well, then it was the shine. Someone's again, true boy? Jeremiah. All right.
He say yes, sir.
Okay. Alicia, are you there still? Maloney? So are you all attending the sessions from the 25th of April, the multiple choice practice sessions?
Most likely.
Yeah.
I guess.
Wait, so it's gonna be at school?
Yes, sir.
Wait, what date did you say was the 21st?
I can't really remember offhand, so let me see if I can get it here.
Either way, we're gonna be home.
Oh, for real? I was hoping that it was in school.
Oh, you want to see us so bad.
You just spread corona.
Yes, I do.
Bro,
No.
it isn't school, you know. You could go in school and do it and just get corona.
Yeah, simple.
Like you're saying
To
it?
be honest, I don't really.
Simple.
No.
Sorry, I lost my
It's
there. I was
from it's from Saturday 25th of April. And this is the whole list of the subjects that are being offered and the dates.
Dog, all you remember the POB thing with the bats with sir? I would still do that, but you can't do that again.
I don't remember.
Is it me and thing though?
Oh yeah.
Yeah, I remember Bala too.
Me too. What? I don't.
Are you
Fuck this
done,
is
sir?
that.
You living in your own world, yes, please.
Yes, sir.
How I living in my own world.
Well, you don't know what you're talking about, buddy.
But you know, remember, says you and Philip.
All right, I'll do all the work.
So,
Uh-huh.
angles on the outside are half of the or double. What would be double of E?
We talk about. So the first one, OAE.
No. Yeah, no. Isn't O double of 48?
No. You asked that question Wednesday too, but no.
Half of 48?
No.
Quintuple of 48?
No. Okay, so let's correct. We have to find angle OEE. Right, that's this angle here. Okay, and as you all can see, it's a tangent that touches the circle there, and the radius goes from the point O to the tangent, and the theorem, which is theorem 7, it says here that the angle formed by a tangent is equal to by a tangent to a circle and the radius at the point of contact yeah. So that being said, that makes angle OAE equal to 90 degrees. Yes, folks?
Yes, sir.
Okay, the second part. Angle AOB. How do you find angle AOB? Well, it's simple. It's just 90 degrees, which we just found up there, plus another 90 degrees. How I got another 90 degrees from? Is over here now, because remember, B will be the same thing, right? B will be the same thing, because remember, it's also touching a tangent here, and the line is coming out from our next radius here. So that's 90 degrees, plus the new 90 degrees that we found, plus the 48 degrees, which is how much? 90 and 90 is 180, and 180 plus 48 is 228 degrees, right? So therefore, it's 360 degrees, take away 228 degrees, which will give us, anybody? 132 degrees. Yes, people?
So I get us this.
Very good.
And I do that same way too, so.
Very good. The third part, okay, so this is the second part. I wrote a little too big. Let me just section it off there. Right. So the third part, angle ACB. So we want to find the angle C. How do we find the angle C? Well, we just found the angle O, which is right here. And we found it to be how much? 130. 30. I can't even write small now. 132. Yes, you all seeing that? Are you all seeing that?
Sir.
Right.
Yeah.
And the rule says that the angle at the center of a circle is twice the angle at the circumference once it's standing on the same arc. So if this is 132 and this is 132 divided by 2, which is
66, 65, 66,
66 degrees.
66.
Yeah. So I'll put the theorem here. That will be theorem 5, which states that angle at the center of a circle is twice that at the circumference standing on the same arc. Anybody got that?
Yeah.
Okay. I hope the people who are quiet are actually following it. Because if you don't try it, you will not know where you are at. Let's look at number 4, the fourth part. We are required to find angle ADB. So angle ADB, if you all realize, it forms part of the quadrilateral. You're seeing it here, I'm outlining it in purple. It forms a quadrilateral here. Right? So we know we're using the cyclic one, right? Because D is part of the quadrilateral. So we know it's equal to 180 degrees. So it's just simply 180 degrees. Take away 66, which is what we just found. We just found C to be 66, so 66 degrees, which will give us
140.
correct. I'll just put theorem here, right? Theorem 6. I don't have space to write it, so you all will just know what theorem 6 is. Any questions so far?
No, sir.
Just going to give you a 1 CXC type question now, and then we go for a short break, right? Well, let me just give you all the question to do first, and then after this particular question, we are going for a break, a 10 minutes break. And when we come back, we're going to do past papers, and then we'll finish class there.
Cool.
Try this question.
So it have any it don't have any 90-degree angles in this, right?
It doesn't have any 90-degree angles.
Yeah,
it does.
asking.
Yeah.
Okay. So I get 212
212, what you got?
calculations were done.
Which using, when I asked you that, I mean, which theorems did you use?
5.
Theorem 5? No.
I mean, no, it's 6.
How much you get?
212.
No. Check back your answer again.
$122.
Close, but no. Remember that's for which part? The first one?
Yeah.
No. Just remember, SW is the chord, right? And SW, if SW is a chord, that makes the circle a semicircle. It splits the circle into half, right? And that's the only hint I'm giving you.
So your first one is 36 degrees.
Correct.
So I get it from start, so I thought that wasn't the answer.
Yeah, you always get it.
No, but big man thing.
Okay, so now you get it.
Okay, this is what I do. Okay, no. Actually, I can't remember what I do, you know. Just now. Alright.
Okay, Khalid. Time's up.
What's the answer for the first part? 36.
Yeah. Okay, so
I can't remember what I do.
the first part, we have to find SAW. Well, we know what SAW is, do we? That's this angle here. That's this entire thing here. Now, if you all notice, SW is a chord in the circle and it cuts the circle into half. So when that happens, the angle that is subtended is 90 degrees. Okay? That's one of the theorems. So let's see. Let me just write it down. The angle in a semicircle is 90 degrees. Okay? So that being said, that means that the entire thing is 90 degrees. However, we can see there only that it's 54 degrees. So how do we go about finding the remainder? It's simply 90, take away 54, which will give us 36 degrees. And that's for the first part. Okay? Next one, we are asked to calculate angle SKF. All right? So as we can see, SKF, it's part of a quadrilateral. So let's see, SKF, it forms part of a quadrilateral. So therefore we know we are using the theorem that relates to a quadrilateral, which is theorem 6, right? which says that the opposite angles of a cyclic quadrilateral are equal. So that goes to say, this time let's get a pencil, that it will be 180 degrees, take away the angle that we were given, in this case is 54. So take away 54 degrees, that's this angle as that angle right there, which will give us 126 degrees. Okay? Third question, third part now. We are asked to calculate angle ASW. So ASW will be the 54 degrees that we just found. Sorry, that we were given, that's this 54 here, plus 62 degrees, that's this here, which is how much? 54 plus 62 is how much? 116. So it is therefore 180 degrees.
I get all that, sir.
Take away 116 degrees, which will give us 64 degrees. Yeah?
Yeah.
Okay, great. That being said, I want you to take a 10 minutes break. It's now 11:51 when it's, sorry, it's 10:51. When it's 11:51, oh gosh, what can I say? When it's 11:01, we are going to resume class, right? Yeah? So whether you are here or not, I'm going to start past papers. So in the time being, I'm going to send you all the handout and the past papers. Okay, can we restart now? Are you all there?
Yes, sir.
Okay.
Yes, sir.
Oh, let me just get the past paper now. Okay. We are given this diagram here, and we are asked to find the value of y. What is the value of y? Anybody can tell me what is the value of y besides Emily and Sandra, because I'm not sure if you all know the answer. Let me call on somebody. Bala, can you tell me the answer? Bala?
He was in the bathroom. He's coming now.
Okay. Okay, how are you want to answer them?
No, really.
We'll try it now. Come now, try it. Look at it here. This is a circle here, right? We have the center O, and we have C here. What is the value of y? C is 50 on, tell me what is the value of y, and tell me why.
Honestly, sir, I want to say 0 because, wait, no, let me think.
Reagan, you want to help her out?
Is it 100?
Yes. And why do you say 100?
Because it's y is twice the value of c.
Correct. So you get that how? Angles that are subtended to the circumference are twice the value at the center.
Can you re-explain it?
Sure. Angles that are subtended from on the same sector, and it's like, so okay, so it's C, it's touching the circumference here. The value at the center of the circle is twice the value of the angle here. That's it, one of the theorem. I'm not saying it exactly as it is, but you get the idea, right? So it's just twice the size of 50, so it's 100. So the answer for this would have been D. It was a multiple choice, by the way. All right? So I want you all, of course, the whole question can't fit on the screen because it's a lengthy question. So you all, I sent it to you all on your phone, on your WhatsApp chat. So do Jan 2017 for me. I'm giving you all a 10 minutes to try that question. Actually, no, I'm giving you all 5 minutes to try that question. So in 5 minutes, I'll ask somebody to share their answer, right? Yes, people?
Yes, sir.
Okay, great.
So breaks are back.
You may have class are back, yes?
Cool.
Okay,
No, I left it there overnight and I'm working in at this way. Morning. Where is that? Where is that? Oh, right.
You all finished?
Almost.
Okay, I'll be right back. Coming back just now.
Cool.
Hi.
Okay, that's correct then.
For HKL, I got 50.
50.
50.
H K L. Okay, let's see. So I'm not gonna draw the circle because that's gonna take forever, right? So I'm just gonna show you all the solution and explain the solutions to you, all right? Does that make sense?
Yeah.
Okay. So here we have we were given, well, this is the original diagram, right? Sanjay, so your 50 is incorrect. We have to find K, the angle K. So remember, angle subtended by a chord, which is HL. This is the chord here, HL, right? At the circumference of the circle and standing on the same arc. That is the rule that we're going to use. So if this is 20 here, and they were given it as 20, that means that here has to be 20 as well. You understand? Everybody understanding?
Yeah.
Okay. And everybody can tell me which theorem is that? That'll be theorem 4.
4.
Right? Correct. Theorem 4. All right? It's quite easy to understand. Once you know the theorems, you don't have to do no big set of weekend. That's the good thing with circle theorems. But it just looks confusing and you have to know which theorem exactly you need to use. That's the only bad thing about it. Okay, now we are asked to find angle JOK. So in other words, we want to find O, right? So from here, we can see that OJ and OK are equal, right? Because they are two radii. So that would make this triangle here an isosceles triangle. And since we know that OKJ, sorry, is 50, and we know that base angles are equal in a triangle, that means that here is also 50 degrees. All right? And 50 and 50 is 100, and 100 take away 180 because angles in a triangle add up to 180. It will give us, obviously, 180 take away 100 will give us 80 degrees. So that's why I got 80 degrees here. Any questions so far? Anybody?
No, sir.
All right. Cheyenne, are you all following? You getting Cheyenne?
Yes, so I get the first one and the second one, but I kind of confused on the third part.
All right, no problem. What about you guys? How are you all? 3 of you getting through?
Yes, so kind of.
Yeah.
Okay. Abraham Lincoln.
Yes, sir. Yeah, yeah.
You're following?
Yeah, but I know when to the washroom, so I know come back.
Okay. Khadija, are you following? I'm just touching base with everybody to make sure everybody okay. Khadija, you there? Okay. Tashana, are you getting through? Tashana?
Yes, sir.
Okay, you're getting through that, right? Okay. Okay, so let's do the next part, the third part. So
I here to research. Thanks for asking.
I know you are there. You're always talking, so I know you're there.
Cool.
Oh, all right. So this we will be utilizing theorem 9. Okay. Theorem 9 says that this angle would be equal to the alternate angle. Well, not the alternate angle, but it will be equal to the angle formed by the tangent to a circle. Sorry, in the alternate set. Wait, let me get my words properly. Sorry. The angle formed by the tangent, which is this angle here, right, is equal to the angle in the alternate segment. So this is the angle in the alternate segment here. That's this here. Okay, people? So if this is 40, that means that here is also 40 degrees. No rocket science there. Okay? Okay, folks? I'm not hearing anybody.
Yes,
Right?
Yeah.
And another method you could have used is this one here. So we have O being the center of the circle. So from O to K, it would have been a radius there. And the rule says, not the rule, the theorem says, that's theorem 7, that if we have a radius touching the tangent, then a right angle is formed, or a 90-degree angle. So that means it's 50 plus something will give us 90 degrees, and 50 plus 40 will give us 90 degrees. So all we have to do was just say 90 take away 40, and we would have got, sorry, 90 take away 50, and we would have gotten 40. Okay, so there were two ways in which you could have done this question. Now I want you all to try May 2017. Of course, use your phone to get the question.
I have this. What? I want to work it.
Somebody was saying something just now?
No, son.
Oh, Sandra, what were we saying?
That I'm finished and ready to correct.
Okay, everybody else or?
Yes, sir.
Okay,
Yeah.
let us see the question then. Sorry, the answer. for May 2017. I will send this to you all on Sunday, right? Because I'm going to give you all a question to do for homework, and you all are required to do it for homework, and then I'll send it to you on Sunday morning, right? When we're having class. After I finish correcting the homework, because remember, I only have homework as well for relations and functions. I told you I would have corrected that on Sunday. So Sunday, I'm going to correct the relations and functions question, which is May 2017. I'm also going to be correcting the January 2017, sorry, January 2019 question. And then on last week, Sunday, I gave you all vectors, which is May 2019. So those 3 questions, in addition to the one I'm going to give you all today, I'm going to be correcting on Sunday, okay?
So all are just for Sunday?
Yeah. This homework was given throughout a period of 3 weeks, you know. And on Sundays,
no, that's the vectors. That's the vectors. Last week, Monday, we did the relations and functions and images.
Nope. Nope. Oh yeah. Right. Great. So yeah. Since then you all had the homework to do, so that's a period of almost 2 weeks that you all had to do these questions, right? And I purposely left it on Sunday because Sunday is when everybody has to come online, and it doesn't make sense I do the homework and correct it 3 times because it's 3 different classes I have. So I said I'll just do it on Sunday class. Okay, so May 2017, the first part, we are asked to calculate angle P. So this is angle P here. So we know that it's a cyclic quadrilateral here, right? So it's just 180 take away 122. Sorry, 180 take away 58, right? And we would have gotten 122. Yes? Because you want to find out this here. This is a cyclic quadrilateral. So we know it's 180, so we just take away 58 from it, and we would have gotten 122. How many? If you get that, show by a raise of hands. Okay, Emily, Reagan, Angelica, Newton, Sanjay, Macy, Jeremiah, Cheyenne. Okay, I hope you all are just raising your hand for style, right? All right.
The 180.
What's that?
The 180.
Where I get 180 from?
Yes, sir.
Okay, so as you can see here, it's a cyclic. It's a quadrilateral, right? R to S, S to Q, Q to P, and P to S. It forms a quadrilateral. And the theorem that I'm talking particularly about is theorem 6. It says that the opposite angles of a cyclic quadrilateral are supplementary. And supplementary meaning it's equal to 180 degrees. So if it's equal to 180 degrees, we know all of this is equal to 180 degrees, and we were given 58. We just take away 58 from 180 degrees, and we got 122. That's just the theorem. You follow there?
Yeah.
All right. So we are required to find angle Q now. So since we know this here is 58, how I remember this question, a question like this? If this is 58, then the center here is twice the size. So it's 58 multiplied by 2, which is 116. This is a question that's quite similar to the one we get in the multiple choice there. Now the question that we got in the multiple choice, that is the only circle theorem question I've seen in a number of years. They keep repeating that question, and it repeats it like about 4 times. All right? So that's a question you will want to familiarize yourself with. However, you still want to try and remember the theorems in the event that they bring a different question. Don't chance anything. However, the one that I put in the multiple choice is the only one that I saw in the past papers that I have. Okay, I've never seen any other circle theorem question, and that question has repeated itself about 4 times. Okay, so that's 116, right? And of course, this is the theorem here. The other part we are, well, okay. So here we can see this is 116, right? And it's obviously an isosceles triangle because of the particular theorems, right? And we know that 180 take away 116. Actually, no, we don't know that it's a isosceles. So 180 take away 116 is 64, right? But what we do know is that the angles in a triangle add up to 180 degrees. So if we know the top here is 16 degrees, sorry, 116, then it's just 180 take away 116, which is 64. And of course, 64 divided by 2 is 32. So that means here is 32 and here is 32. So that makes this a isosceles triangle. Everybody okay? This is the working here for it. Any questions? If you have a question, you can raise your hand. Okie doke. Your homework for this class will be May 2019, okay? That's the last question on this paper. However, now I want you all to do January 2018 for me. Now?
Hey, so we're not taking the extra 30 minutes, right?
Nah.
All right.
What do you mean the extra 30 minutes?
Remember, every class I told you I'm going to take an extra 30 minutes just so we can finish the syllabus.
Yeah.
It's not necessary for today's class. In fact, we might finish like around 10 minutes earlier. So
hopefully.
Unless all you want the extra half an hour.
No, we're good.
So we can finish all now after this question, yeah, but
Big fact.
Yeah, after this question, we'll definitely finish. So I'll give you all 10 minutes to do this question, and then after this question, we'll certainly finish.
I don't know if you're being sarcastic, but okay.
No, I'm actually being serious. I am hungry and I want to go and sleep and watch TV and so.
Alright.
That is advising.
So for the first part is 72.
Probably.
Alright. And for the second part is 123.
Probably.
Okay. You could scroll on a little bit more.
You have it on your phone?
Yeah, but I'm using my phone as my calculator.
Okay. So that's the second part.
before we tell you.
So I done it.
Okay, great.
We waiting so long for all these other people. I will finish
Yeah.
AE.
Oh, wait a
So
minute
since I
again.
finish, I can leave so and just send my answer to you.
No. If you leave, I'm gonna put you absent.
So you doubting me, like you know.
Okay, let us correct. Jan 2018, right? So as you all can see here, that, hold on. Let me see the question. Okay, so this here is 114 here, right? So this is 114 over here. As you all can see, this is 18 here. Okay, you all seeing it?
Yeah.
Right, and a half of 114, let me just see the next question. Let me just see about the question, right? This is 18. Right, so if this is 18, a half of 114 is obviously 57. So that means here is 57 because if over here is 114, obviously over there will have to be 57, right? And the reason is given over here. So how many of you got 57?
Me, William, Tyson.
Don't forget Mohammed.
Yes.
Right? The other part, we were asked to find angle AED. So E, we were asked to find here. How do we find E? Let's see. It's so OAE is equal, OAE is equal to ODE, right? So the angle between a tangent, which is EA and ED, to a circle, and the radius OA and of course OD at the point of contact AD is a right angle. So that's here. This is a right angle triangle here. This is a right, sorry, not a triangle. This is a right angle here because this is the radius that touches the tangent, and this is a tangent here as well. So this is 90 degrees, and this is 90 degrees because it's perpendicular, right? That's what the theorem is telling us. So that means that 360 degrees take away 90 degrees here, and the next 19 degrees here, and 114 degrees will give us 66. So that means that here is 66. Again, if this is 90, this is 90, that means that 90 plus 90 plus 114, and when you take it away from 360, you will get 66, because 90 plus 90 plus 90 plus 90 is 360, right? Well, of course, it's not 90, it's a little more than 90, but all the angles in a quadrilateral add up to 360. We did that when we did quadrilaterals, right? So again, 90. What's that?
90 plus 90 plus 90, that's 276.
Plus 114 is 194, and take away 360, you'll get 66. But 90 plus 90 is 180 though. I don't know how you get 270. 90 by 3 is 270. But anyway.
You say 90 by 90 by 90?
No, I said 90 plus 90.
Plus 90.
Yeah. But if I said by, I'm sorry. Okay, let's look at the third part. So we are asked to calculate angle CAD, right? CAD. Okay. So CAD, you all seeing this screen here, right? With the colorful things on it, you all seeing it?
Yeah.
Okay, just
yes, sir.
Right. So the angle between the tangent, which is DG, to a circle, and the chord DC is equal to 18 degrees here. They gave us that in the question, right? Yeah. And obviously, this here is an alternate segment. DAC is an alternate segment. So that means here has to be 18 degrees as well, because this entire thing is 33. So that means that here has to be 18 as well. Okay? Let me just explain it one more time. This is 114 degrees. As you all can see here, it's 114 degrees, right? So 180 take away 114. It's 66. And of course, it's a triangle, so all the angles have to be equal to 180. So 66 divided by 2 will give us 33, and that's why I got 33 here as the base angle. Right? Base angles are equal to here's 33 as well. So because of this, the theorem here, it's telling us that the angle in the alternate segment is equal to 18 as well. So that means it's here. Yeah? Yes, folks? So that means here is 18. Now, that being said, we are seeing here a triangle OAD is isosceles. So that means that OA and OD are equal to each other. It's supposed to be OD here, right? Because they are both radii. So angle OAD, so OAD and ODA will also be equal to 33 degrees. I just showed you all that. 180 take away 114. And of course, I divide the answer by 2 and I got 33. All right. So if we want to find out the angle for OAC, it's just simply this 33 here, which is the entire thing, take away the 18 that we just worked out here, and we would have gotten 15 degrees. How many of you got 15 degrees? Show by raise of hand.
Liam.
Oh God, look how many people lying. Just kidding.
Oh, you know if we lying.
That's what I said. Just kidding, Kaleem. It's called a, never mind.
Oh, the joke, Kaleem.
Okay.
Yeah, I don't think Kaleem understands that much.
Says you wanna feel, but
Huh?
I don't think he understands anything.
you said what? Kaleem, you shouldn't be the one speaking, okay?
Yeah, Kaleem. If I was you, Kaleem, I'd just mute my mic, right?
too.
But that's only if I was you, right? Only if I was you. I'm not you. Anyway.
He's not me, so right.
Yeah.
I understand.
Okay, so 2 minutes again. Let's see how fast I can finish this in 2 minutes so we can go 10 minutes earlier, right? You're all welcome, by the way. So A, B, C, we are finding the angle B. So the angle ADC, right? So ADC, obviously this is a cyclic triangle, right? Sorry, a cyclic quadrilateral. So it's 180 degrees, and it's 180 degrees. Take away the 18 degrees that we got here, plus this 57 degrees that we have here, which will give us 105. So that means this angle here is 105. Sorry, I completely said craziness. This is a triangle here that's being formed, right? This is 18 degrees, and this is 100. This is 57. And we know that the angles in a triangle add up to 180 degrees. So 57 plus 18, right, is 75, and 75 take away 180 will give us 105. So that's how we know 105 degrees is here, because it's a triangle. So forget what I said about the cyclic thing. Now we're going to use the cyclic theorem. So we're looking to find angle B. That's this angle here, right? So since we work out this to be 105, we know for sure this is 105. We can't use this 57 or this 18 here because this is just piece of this angle here, right? But we know for sure this entire thing here is 105. So all we simply say is 180 take away 105, and we will get 75. So that means that this angle here is 75 degrees, and that is it. Any questions?
No, sir.
We finish?
Yeah, we are finished, Kaleem.
Okay, I'll leave it, right?
Okay, bye. So you all have a good carnival. Sorry, hear me carnival. Have a good.
No, sir.
You're going to carnival?
Have a great Good Friday. Enjoy the rest of the holiday. Spend time with your family. I know you all have a choice.
So I can't wait
now.
to see you on Sunday. I can't wait to see you on Sunday.
To see me on Sunday? Oh, that's so kind of you, Bala. But you won't be seeing me though. You'll hear me.
Oh, be sarcastic.
Shut
Bye,
up.
sir.
Goodbye. Have a great day, everybody. Bye.